All right, so moving on to section 4. Kind of got a boring background here, but we are moving on to section 4, which is about combining random variables. Okay. All right, so let's say we have these two different random variable probabilities. And so they are independent of each other, they are separate, there's no connection between them. And so we have the probability of x being 1, 2, 3, as shown, and the probability of y being 5 or 10, as shown. Now, the question that we're going to be looking at is what if we want to combine them? So, what if we want to say x and y occurring, addition of them? So, what we would do is that we'd take each x and y and we add them up. So, 1 plus 5 is 6, 2 plus 5 is 7, 3 plus 5 is 8, and that's how we get our S, our sample space on the bottom. And then we would take each probability, okay, is shown below, which would be 0.16, 0.18, and so on and so forth, okay? And to do each one of those, we basically have taken each probability and multiplied them. So 0.3 times 0.4 is 0.12. 0.3 times 0.6 is 0.12. And so on and so forth. Okay. All right, so that's how we get this new sample space. So now what we want to do is we want to find the expected values and all that. So using your calculator and the formulas from the last section, we can find the expected values and the standard deviations of each. Okay. And so those are these numbers as shown. Okay, so if you want to check it, you can practice using those numbers and those formulas, okay, and you should get these numbers for them. Okay, so you see our expecteds, and then our S and our X and Y, S, X, Y, so on and so forth. Okay, so we have all those, which you can use your calculator on, obviously, for calculating that. Now, if we only had two, and not very many points, it's not that difficult to do it. But what if we had a lot of different outcomes for each, and we wanted to find them a quicker way instead of just making a brand new table and doing that? And so if you don't want to make a brand new table, you can use these formulas for when you're adding or subtracting these independent events. So if you are adding independent events to find the expected value, you take the expected value of x and you just add it to the expected value of y. And that should get you your new expected values of both of them, of x plus y. And subtracting is just the subtraction of x minus y, if you're taking the x values minus the y values to get your new one. So you don't have to make a brand new distribution table to find these. Okay. The bottom part is the standard deviations, and as you notice with the standard deviations, they are exactly the same for both adding and subtracting, because the standard deviation is just talking about the spread of it. It doesn't care about what the exact x or y are. Okay, what the mean is, it's just talking about the spread. And basically what's happening is that you're taking, think of like a bell curve, and you're just either taking that bell curve shape and either sliding it up or down depending on if you're adding or subtracting, but the standard deviation is the same. It's sigma x squared plus sigma y squared, and then take the square root of the entire thing. Okay. But if we look back at this one, you can see the x, y, if you add them up, you get close to that 10.24. Rounding error here and there, depending on what the calculation is on how much you round. Sig figs and stuff from sciences. Okay. Next up is the linear transformation of it. So this is if you are doing a straight increase of something, kind of a vertical shift up or down. Okay. So let's say we have this distribution table. So everyone at Google is getting a randomly assigned salary, 50, 60, 70, or 80,000. And the PX below them are the probabilities of each one occurring. So 0.2, 0.3, 0.4, 0.1. So the first question, which take a second, find the standard deviation and the expected value of this distribution table. Okay. And when you used your calculator, you should notice that you get your expected value as about 64,000, and the deviation was approximately $9,165.15. That 15 cents is important. Now, that's your expected and your standard deviation for those. Now, moving on to the next thing, what we want to do is we go, okay, everybody gets a $500 bonus. How does that change the expected and the standard deviations? Okay. Now, if we're just adding 500 to it, what essentially happened would be all these X's are now becoming 50,500, 60,500, 70,500, 80,500. So it's just increasing by 500. So what do you think is going to happen to the expected value? It's also going to increase by 500. Okay? So the expected value would also increase by 500 because everything is being increased by the same amount. Since everything's being increased by the same amount, we would not have to worry about any crazy drastic change in the expected value. Now, the standard deviation does not change because, like I mentioned earlier, you're basically taking that bell curve or that normal distribution and you're shifting it up or shifting it down. You don't have to, it's not going to spread it out or shrink it in any way if you're just adding 500 to it. Okay. All right, so let's say they want to change their salaries and this 50,500, 60,500, 70,500. So we have the $500 bonus. Let's say everybody gets paid in $100 bills. Nice Ben Franklin's. Okay. So the question is, how many $500 bills will they get? Okay. So what happens is that the X value changes. It now goes from 50,500 down to 505. Okay. Everything gets divided by 100. So since everything's being divided by 100, the expected value and the standard deviation are both going to be divided by 100. So you take both those values and you're going to divide it by 100. So if you're adding something to it, you are just going to increase the expected value by that much. The standard deviation doesn't change. But if you are doing a product, a multiplication, a division of the number, then you have to adjust both the expected and the standard deviation. Okay? And they both are going to be affected the same way. In this case, they are affected by dividing by 100. Okay? So, general transformations. The expected value of A increase plus BX is just going to be whatever the original is just the expected value multiplied by B and then adding A to it. So this, the A, is your first change, okay? While the A was the increase by $500 example, and the B was dividing by 100. Okay, that's the A and the B. So if you're just adding something or subtracting, you just add or subtract it to the expected. If you're manipulating it by a multiplication or a division, it's going to have to be attached to that. But the expected value is different from the standard deviation because the standard deviation doesn't change if you are adding or subtracting. All right. So let's do an example with hot dogs and sodas that are being sold. So, at a given minor league game in this example, depending on attendance, there's a probability of how many hot dogs and sodas are sold. So this is showing 100, 200, 500, 1,000, 2,500 for the hot dogs, and 100, 200, 400, 800, and 1,500 for the sodas. So those are the probabilities of each. Okay. Now, we want to know if the profit for hot dogs is $1.50, so every hot dog they sell, they make $1.50, and for every soda they sell, they make 75 cents. Okay, it's probably reversed in real life on that, but if that is the profit, we want to know what is the average profit or the expected profit of hot dogs and sodas per game, and then we also want to know the standard deviations of the profit. Okay, so with this, we want to find, the question is asking what is the expected profit and what is the standard deviation of the profit. So how much spread does it have? Now with this, first thing we have to do is find the expected and the standard deviations of each hot dogs and sodas. Okay, and you would do that just like you would with any other data table. Okay, finding the expecteds for them. Okay, so the expected values of those would be expected for hot dogs is 1,025. The standard deviation of the hot dogs is 793. Expected for the sodas is 680, and the standard deviation was 476. Okay, so that's your expected and your standard deviations for those. And now, what's being manipulated? Well, we are multiplying. We're trying to find the profit. So the hot dogs we make a profit of $1.50 per hot dog. So if they sold 1,025 hot dogs, you'd multiply that by 1.5 to find the expected value of the profit of hot dogs. Sodas would be 680 times 75 cents. And since those are being multiplied, we'd have to multiply those, but then we're just going to add them together. So we would just add the X and Y's together. So the expected value for the hot dogs ends up being 1.5 times the expected value of hot dogs plus 0.75 expected values of the sodas, which are our E, H, and ES at the top of that table, and then you just add them together, $2,047.5. Okay, and now our standard deviation, we'd have to go back and use our square root formula, so it's the square root of the sigma squared plus sigma squared. But since these are both being manipulated by multiplication, okay, they're being increased or decreased based on a multiplication, 1.5 or 0.75. We have to multiply each one of those standard deviations. So we'd go 793 times 1.5, then square it, and 0.75 times 476, and then square it. Add them together, then take the square root, which was the standard deviation formula at the beginning that I gave you of this lesson, okay? And so the standard deviation of the hot dogs and soda profit would be $1,241.90. All right. Okay, so last example here. So we got two bowlers, and then this is just the data table. So this is just the information you need. So you've got the mean and the standard deviations of each one of Larry and Sam bowling. They're pretty good bowlers with like 200 and something. I mean, that's pretty good. And so now what we want to do is we want to find each one. So looking at this data that was given, take a second and find the expected value of S or L plus S, the mean of the difference of S and L, the standard deviation of L plus S, 3 times the deviation of L, the deviation of L minus S, and the expected value of 4 plus 3L. All right, so look at this. Let's look at all these. So the first one with the expected value of L plus S, we were just adding them together. So you're basically asking what's the expected score of both Larry and Sam's combined, which is that. The next one is asking what is the average difference between their score, which would be between Sam's and Larry's, and which that should be 12, because it'd be 221 minus 209. Standard deviation of their scores combined, so added together, would be 14 squared plus 22 squared, which gives us 26.08 squared. The 3 sigma L is just taking whatever sigma L is, and which is 14, multiplying it by 3, and that gets you your answer. Fifth one down there, sigma L minus S, is the same as the one above it, sigma L plus S, because remember the sum and the difference of standard deviations are exactly the same. There is no difference between them. So if you're adding or subtracting for the standard deviation, there's no change in it. And the last one, the expected value of 4 plus 3 times Larry's score. So if you triple Larry's score and then add 4, what's the expected value is essentially what's being asked here. So it would just be 4 plus 3 times 209, which gets you 631. And that is how we do it in AP Statistics. So with that, that's the end of section 4. We've got one more section to go, and then you are done. All right, with chapter 4. So homework for this one is section 4. I think that will be it. Section 5 is a fairly long one, so just get prepared for that. All right, good job.